back, students. Today we will be doing a very important topic of the mirror, which is the mirror formula. Okay. When you open the textbook, you will see the mirror formula given as 1 by f equal to 1 by v plus 1 by u. Okay. Where f denotes the focal length, v denotes the image distance. Okay, and u denotes the object distance. Okay, now what is this? Let us see in detail. Okay, suppose I'll just consider it. Suppose here is a concave mirror. Okay, now you will be remembering what are the parts of the mirror. The center of the mirror is called the pole. The axis passing through the pole is known as the principal axis, right? Then as it will have the center on this side, so this is called the center of curvature, and the midpoint of it is known as the focus. Okay, right? Now the length, all the measurement have to be done from the pole of the mirror. Okay, now the length of the focus, this is the focal length. All right, this is the focal length. Now depending upon where the object is, its image will be made, right? Now let me take one just example. Suppose when the object is beyond C1. Okay, when the object is beyond C1, then the image of it will be formed somewhere, like when the object is nearer to C1, right? Then the image of it will be formed at in between F and C. I'm just taking it. Okay, you can see how it is formed. Like when the object is very far away, the image of it will be formed at the focus. When the object is approached nearer and nearer, the image of it will be shifting away from the focus towards the C. So all these things in another separate video I have told you, so you can have a look. So when the object, this is an object, let me call it object, and this is its image. Okay, now the object distance from the pole, in this case this is what? This is u, right? From the pole, all the measurements have to be made from the pole, and this is the image distance. This is the this is the v, image distance. Okay, so v I have written image distance, u object distance, and f is the focal length of the mirror. Okay, and you have to apply this what are the given things in the formula. But before applying this formula directly, you need to remember the conventions. Okay, and the convention, I normally I find it easy to go this way. See, the convention is left is negative, left convention is negative, and right convention is positive. Okay, right convention is positive. Keep these things in your mind. Okay, and upward, for the height, upward convention is positive. Okay, and the downward convention is negative. Okay, what is this? We'll see. Downward is negative. Okay, now in this case, okay, let's take this case where the object is on the left side or on the right side. This is from the pole. All the measurement have to be from the pole, right? From the pole, the object is on the left side, so you have to be what? Minus. All right, now coming about the image is on which side? Left side or right side? From the pole, it's still on the left side, so what it need to be? This have to be negative. All right. Now coming about the focal length, it's still where on which side? It's still on the left side. So what it is? Focus. So this U, V, F can either be negative, either be positive. If it is on the left side, it have to be what? It have to be negative. If it is on the right side, it has to be positive. Okay, fine. Now coming for the height, like the object cannot be down, upside down, right? So the object height is positive, but the image, how it is upside down, this height is negative. All right, so this upward and downward convention is for the height, while for the distance, the left and right convention. Okay, so depending upon the situation, we can use the things accordingly. Okay, then we can use that one and the mirror formula. Okay, now I will take one example. Okay, let's see, in the text a number of examples have been given. Now I'll just take one or two and try to explain the things. Okay, let's see, here is a convex lens, or let me take a convex mirror. Okay, let me take a convex mirror. All right, convex mirror, you know, in an automobile, side mirror is a convex mirror, right? Like let's say this is the way. Now this is what? This is a pole, right? Then there will be some focus, there will be, what to say, center, right? Now let's take, I'm not writing the question, I'm telling you the situations. Okay, suppose here is a truck. Okay, here is a truck. Now side mirror it is. Then when it is seen through the convex mirror, how the truck will be going to look like? The truck will look like a small quantity, so it looks like a small one, right? This is the object, this is the its image. All right, now let's say some of the parameters are given in your question. Let's say U is given as, okay, I'm taking it. Okay, let's U is 20 meter away. All right, means what? Where the truck is? The truck is 20 meter away. All right, and its image is nearer, right? That's why sometimes you have seen that in a side mirror, objects in the mirror appears nearer than they real are, right? So as it is nearer to the pole, right? Let's say this is 10 meter. All right, fine. The question says find the focal length of the mirror. Okay, fine. Okay, now first of all, you know, U is given to you, V is given to you, you have to find F, right? Now what you are going to do, you are going to use a formula, simply 1 by V plus 1 by U, right or not? Now tell me whether U is plus or minus. U is on which side, student, from the pole? U is on the left side, right? So for the left, what is the convention? Negative, right? Where the image of the truck is on the right side, right? So it have to be what? It have to be positive, right? Fine. Now can I do all the what to say? Now can I solve it? Yes, I can quickly solve it. Let's say 1 by F is equal to, the rest is now mathematics only. So 1 by 10 U plus, and by their minus, so what is will be 1 by 20. Then if I take the LCM of it, 20 and 10, 20, this one will be, then this is 2, this is 1, and this will be what? This is 1 by 20, right? Then this will be what? 1 by F is equal to 1 by 20. Now if I do the cross multiplication, then the focal length is what? Focal length is plus 20. It's in meter, so this is 20 meter. Then what does it mean? it means it's positive, right? It's positive. Positive means what? Right. So the focus of this mirror is on the right side. How far away the focus is from the pole? It's away, what to say, 20 meter away. All right. So if you know this type of what to say, mirror formula, you can check in the book. Before using the mirror formula, you have to apply the convention of left, right, upward and downward. Okay. Now sometimes in case of, like, even in this case also, for the bigger object, smaller image it is. So in order to explain that, we have a term which is known as a magnification. Okay. Magnification basically means how much, how big the image is relative to the object. Okay, so that comparison is known as the magnification. Okay, now by definition, magnification, magnify, right? Magnify is what? It is height of image. All right, height of image divided by, compare with the height of the object, height of object, right? All right. And normally the textbook has written as h dash by h. Okay, you can use even h1 by h2 also. H dash implies the height of the image and h is the height of the object. Now in this case, is it magnified? Is the image is magnified? No, right? So in this case, the magnification will be less than 1. Okay, now in this case, though the height of the truck is not given, even the height of the image truck is also not given, there is another formula for the magnification, and that is in terms of v and u, and this is minus v by u. This you need to remember it. Okay, now minus is there already in the formula. V was how much? V was how much it was, I completely, if I'm not mistaken, v was 10, right? And how much u was? Minus 20, right? U was minus 20. So this is equal to what? This comes as 1 by 2. This is less than 1. This is 0.5. Means the image of the truck will be half of that of the original truck. Okay. So if the truck is 10 meter height, then the image will be 5 meter. Okay. So this is about the magnification of the, what to say, mirror. Now just similar with it, we can have for the lens also. Okay, here in place of plus there is minus in the formula, and the magnification, the formula is the same, h dash by h, but in terms of v and u, it is v by u only, no minus is there. Okay, now we can take the questions like, suppose here is a convex lens. Okay, I'm doing it. The conventions will be the same. Okay, now all the measurements in this case will be should be from the optic center. Okay, now I'm choosing this one as 2f1, this is as f1. Okay, this is f2, and this is 2f2. All right, now let's take general case. Suppose the object is at here. Okay, object is at here. Okay, then where the image have to be? The image have to shift. The image have to shift behind this, right? Bigger in size, right? Okay, now this is what? This is object distance. Okay, and this is what, student? This is image distance. This is v. Right? Now, u is positive or negative? U is on the left side. The object always have to be on the left side. So u is what? Minus. And what the image is? Image is on the right side. So v have to be plus. Okay. Now coming about the focus. Okay. There are two focus, left and right. Okay. Remember one thing. For convex lens, Okay, f is always positive. Okay, on the contrary, for the concave lens, f is always negative. Okay, so if you are able to know this, we can be able to do a number of questions. Okay, so let us quickly make a question. Okay, let's take a question then. All right, let's say u is equal to 10 centimeter. All right, and v is equal to, let's say, 20 centimeter. All right, the question is again find f. All right, now f have to be positive, we need to remember it. Okay, this is for the convex lens. Okay, now u have to be what? Minus, and v have to be plus, right? Now if I use the lens formula, this will be what? 1 by v minus 1 by u, and v is 1 by 20, and this will be what? Minus, and this will be 1 by minus 10. This is plus, minus and minus will be plus. So 1 by f is equal to what? 1 by 20 plus 1 by 10. If we take the LCM of it, this will be 20, 1 plus 2, and this is 3 by 20. Okay, 3 by 20, and this is equal to 1 by f is equal to 3 by 20. 3 by, if I just cross multiplied it, f is equal to what? 20 by 3, and if you divide it, this will be 6.6666. It will continue 6.67 centimeters. So where the focus is? The focus is approximately 6.67 centimeter away, and this is, remember, this is plus. Okay, now coming about the magnification. Here also magnification the same way we can do, but it is v, not minus, right? So we can do for the magnification is what? V by u, and v is 20 and u is what? Minus 10, right? So this is what? Minus 2. Now this minus for magnification talks about the height, right? So 2 means what? The object image is double. Minus says what? Upside down. Okay, so students, see the textbook, learn from the textbook. You will be clear. With that, I'll conclude the first chapter. Thank you.